Hey, sixth graders, this is lesson 8, day 3. So we are going to be doing some more division, but we're going to be doing it with some bigger numbers. So let's get started. If your book is not on page 86, 87 right now, pause this video and go get it. Then restart it and continue with me. All right, so let's start with the problem here and follow along. It says Sam's father bought a new car for $26,304. He expects to pay for it in 24 equal monthly payments. How much will Sam's father have to pay each month? So first, you got to know why it is division. Sam's father is taking the total amount he's paying for the car and splitting it into 24 equal payments. So anytime you're splitting that amount, that's going to be division. So first off, it says estimate it. You can use compatible numbers to estimate the solution. So when you're estimating in division, you usually don't change the divisor that much, the second number. It's usually the first number you want to make. So notice $26,304 is close to 24,000. So if I were to change it to 24,000 divided by 24, this would be an easy problem to estimate because 24 divided by 24 is 1. Add the 3 zeros. So Sam's father is going to pay about $1,000 a month for 24 months. That's a lot of money on a car, just saying. All right, so now model it. It says you can use the division algorithm to solve the problem. Now, what I've done is I've whited out what the book had here because on the left, I'm going to use the typical division algorithm, and on the right, I'm going to use partial quotients just for both people. Now, before I get started for both, I'm going to do a little bit of a counting by 24 list. So 24, 48, 72, 96, 120. There's the first 5. I could add one more real quick, 144. And remember, you can just add, so 144 plus 24, that's 8, 6. Next one will be 168. Doesn't take that long to do your counting by list. All right, so now, let me get rid of that a little bit. Okay, so let's start. On the left, we'll use the traditional division algorithm here. So 24 does not go into 2, but it goes into 26 one time, which is 24. So the 24 goes under here. Every time you subtract, you must bring something down. So my new number is 23. Now 24 doesn't go into 23, so you have to say it goes in 0 times, which is 0. Every time you subtract, you must bring something down. So my new number is 230. So what I'm going to do real quick is continue my list. I have 1, 2, 3, 4, 5, 6, 7. I will only need 2 more. So 168 plus 24 is 12 is 192. And 1 more plus 24, that's 6, 11, 2 is 216. All right, so how many times does 24 go into 230? It goes in 9 times, which is 216. Subtract and bring down the 4. Okay, so 24 goes into 144. 1, 2, 3, 4, 5, 6 times, which is 144. No remainder, nothing to bring down. So Sam's father will spend exactly $1,096 per month on the car. Now, how would you get that using partial quotients? So over here, I'm going to use partial quotient method. So check it out here. Let's get started. Okay, so remember how 24 went into 26 one time, right? So if we know 24 times 1 is 24, 24 times 1,000 will be 24,000 because you just add your 3 zeros. So it's going to go in 1,000 times. And remember, that was our estimate up here. That's a good way to start. And what I do is I subtract 4, 0, 3, 2. So I'm down to 2,301. Now, 24 into that. So if I were to say 10 times, that's too many. So what I'm going to start with is, let's say, if it goes in, if 24 times 9 is 216, 24 times 90 would be the 216, but add a 0. I have 4, 4, 1. I'm down to 144. And then last, we know 24 goes into 144 6 times. So add up my partial quotients. 1,000 plus 90 plus 6 is $1,096. You get the same thing, but some people like doing it with partial quotients better. All right, so what we did so far is we estimated Sam's monthly payments by coming up with compatible numbers, friendly numbers, got about $1,000, and then we came up with the exact answer. So now we're going to go to the next page. So here's what I want you to do. I want you to work on 10 through 13 on your own. You're going to pause the video while you do it. If it says to explain, make sure you explain. If it says to show your work, make sure you show your work, however you did it. All right? If you have a question like 13, why is it important to pay close attention? Questions like that might not be a wrong answer. So give it your best shot. Do 10 through 13 on your own. When you're done, restart the video. Go. All right, so let's see how you did. Let's get started. So 10 says, how much will Sam's father have to pay each month? Is that answer reasonable? Explain. So we figured out that Sam's father will have to pay $1,096 each month. Now I'm going to say that's reasonable because remember when we did our estimate? If we said he's going to have to pay about $1,000, $1,096 is about $1,000. So comparing your real answer to your estimate is a good way to tell if an answer is reasonable. So I'm going to say yes. I estimated that Sam's father will pay, about $1,000 per month. And I would say 1,096 is close to 1,000. So I know it's reasonable. Now, if you had something similar or in your own words, don't change it. But if not, you could always pause the video and write down your answer. Now, 11 says, look back at the division algorithm. What is 24 times 1,096? So let's go back here. So we know when we divided, let me switch to purple, that $26,304 divided by 24 was 1,096, right? So we can use the opposite and say that 1,096 times 24 will get us 26,304. All right? So what is 24 times 1,096? We would say 26,304. And we didn't even have to do any multiplication work. Now 12 says, suppose Sam's father decides to pay for the car in 48 equal monthly payments. How much would he have to pay each month? Now, it says show your work. And yes, you could do 26,304 divided by 48 and get the right answer. But I don't feel like doing that. I want you to think about this for a second. So we know Sam's father is splitting it into 24 group payments, right? Which was $1,096 per payment. Well, if he goes from 24 to 48 payments, he's doubling the amount of payments because 24 times 2 is 48. So that means if you double the amount of payments, you're paying twice as many payments. So because you're paying twice as many payments, your payments have to be exactly half as much. All right? So let me show you what I mean. If I take the 1,096 payment and cut it in half, or divide it by 2, I will get the answer to this division problem, and I'm going to prove it to you. So, and this is much easier to do. 2 goes into 10 5 times, which is 10. Subtract, bring down. 2 goes into 9 4 times, which is 8. Subtract, bring down. And 2 goes into 16 8 times, which is 16. Now, are you ready? But I get 548 over here. So let me get my eraser ready. Okay. So now, 48 is going to go, it doesn't go into 2 or 26. It's going to go 5 times into 263. And I'll prove it. So 48 times 5 is 40. 5 times 4 is 20, plus 4 is 24. It's 240. I'm going to subtract and bring down my 0. Now 48 is going to go into 230 4 times, because remember 5 times was 240. That's too high. So it's going to go 4 times. 48 times 4. 4 times 8 is 32. Oops. I write the 2, carry the 3. 4 times 4 is 16, plus 3 is 19. So it's going to go 4 times, which is 192. Now, every time I subtract, I must bring something down. So I subtract, I get 38, bring down the 4. Now 48 goes into 304 8 times. And 48 times 8, 8 times 8 is 64. 8 times 4 is 32, plus 6 is 38, is 384. Holy crap. But wasn't it much easier to just split the 1,096 in half to get 548? I think so. Either way, if you had $548, you're good. Make sure you have some kind of work shown. Either that if you divided by 48 or if you used my trick there. Now 13 says, why is it important to pay close attention to place value when dividing with the division algorithm? So let me explain it here. Let's say I go up to this answer where I had 548 here. But let's say I started the 548 over here and had my digits not lined up. You would probably say, oh, I need something above the 4 and add a 0 to get 5,480, which is wrong. Okay? Or, let me undo all that. What if I started my 548 over here and I got through the 5 and the 4 and I might have 54.8 because I know I would have to have a 0.0 there. So if you don't keep your digits lined up and your place value accurate, you're going to get the wrong answer. So why is it important to pay close attention to place value when dividing? Okay, it's important because your answer can be too big or small if you aren't lined up correctly. Okay? So, we're done with 10 through 13. But now, are you ready for the last 2 problems? Okay. So, this says, use what you just learned to solve these problems. Show your work on a separate sheet of paper. So, you are going to do 14, and you're going to do 15 on your own, and then you're going to start the video. Now, you may do, if it's division, you may do the division algorithm. You may try partial quotients. I don't care which. So what I'll do is I will probably go over this first one, number 14, partial quotients, assuming it's division. And the second one, I'm going to use the division algorithm. So if you want to do it the same way I'm doing it, you could do that. But if you just want to do it your own way, go for it. Be my guest. All right, pause the video, do 14 and 15, go. All right, so I just created some workspace so I can do 14. 14 says in a year or 12 months, a sports team practiced for a total of 1,305 hours. On average, how many hours did the team practice each month? So when it says on average, they want you to split those 1,305 hours up equally into 12 months. So we're going to divide that by 12. So I said this one I'm going to do partial quotients, right? So I'm going to do 1,305 divided by 12. Now, if you did the traditional division algorithm, just make sure you have the right answer. So I'm going to start by doing a little bit of a counting by 12 list. So 12, 24, 36, 48, 60. I have to add one more, 72. I can add more later if I need them. So 12. I know 12 times 1 is 12, right? So that means 12 times 100 would be 1,200. Just add the 2 zeros. So 12 times 100 will be 1,200. Okay, when I subtract, I'm down to 105. Now I'm going to put 12 into 105. I'm going to keep counting. So this is 84, 96, 108 is too big. So it's going to go 1, 2, 3, 4, 5, 6, 7, 8 times, which is 96. Subtract. 15 minus 6 is 9. So at this point, because there's nothing to bring down, here's what I'm going to do. I'm going to combine these and say 108. And instead of saying remainder 9, I'm going to use the fraction 9/12. So 108 and 9/12 hours. Now, I also know 9/12 reduces to 3/4. So I can say 108 and 3/4 hours. All right, so I don't want to use a remainder because that's kind of a little bit babyish in that respect. Okay, so now, if you said remainder 9, just fix it. Now, you ready for number 15? I'm going to do this one traditional, so. All right, so 15 says, there are 1,891 students participating in the citywide holiday concert. A bus seats 62 students. How many buses will be needed to bring the students to the concert? Ooh, this one tends to trick some people, so let's see if you got tricked. So first off, what we're doing is we're taking the 1,891 students and we're splitting them into groups of 62, because each group of 62 is a bus. All right, and our answer, our quotient, will be however many buses we have. Now, I'm going to start by doing a little counting by 62 list. So 62, and I have 124. Now I'm going to do a little bit of math down here. So 124 plus 62, 681 is 186. Plus 62, that's 8, 14, 248. I'll do one more. 248 plus 62, that's 10, 11, 310. All right, that will give me a starting point. So now, let me continue here. So 62 doesn't go into 1 nor 18, but it will go into 189 3 times, which is 186. Now, when I subtract, I get 3, bring down the 1. Now, 62 goes into 31 0 times, which is 0. Subtract 31. Now, at this point, we could say, oh, you need 30 and 31 62 buses. Or maybe you're like, hey, that reduces to 30 and a half. But can you have half a bus? Well, you could if you cut it in half, but you ain't going anywhere on it. So this one, the question says how many buses will be needed to bring the students. So this remainder of 31 is 31 leftover students. So you need to take that answer and say you'll need 31 buses. All right, so if you did not get tricked and you knew you needed 31 buses, you're kicking butt and taking names. Anyway, guess what? You're done with me. If you made any mistakes, please pause the video, make your corrections, and thanks for watching.